So the next topic, and I think the last topic that we can possibly cover in this class, is going to be about inheritance. File, close solution, right? That's the way to deal with it. Then my solution, which I was using today, was this substring demo thing. When you go here, you typically would like to get rid of this SDF file. Look, it's 8 megabytes. So get rid of that. Typically Shift Delete will permanently delete the file without placing it in a recycle bin. And you also want to get rid of debug and IPCH, which is the precompile headers. Also Shift Delete, permanently delete. Then you can go here and use your favorite archive utility to create an archive. I typically go with the substring demo, the 7-zip format. It's very reliable and is used by many other automated scripts. It's available on it's cross-platform. So this is the file which I just created, and this is the file that I will be saving to post on the website. I'll probably clean it up a little bit before I post it and maybe add some comments in general. So I already saved it. So anyway, just a reminder that it's a good option that you can copy, and if you want to make a copy of it, right? So I was somewhere here. If I wanted to move to the next level and preserve the older one, I would typically string demo, say copy, and then paste it instantly. And you can basically preserve this, rename it as version 1, right? So the next version you're going to be working on is going to be this thing, and then if you need to preserve it, you can right click, copy and paste, and make it version 2, version 3, and this way you can maintain multiple versions of it. By the way, if you go to version 2, 3, or 4, you can still go ahead and open the solution file and it'll load it for you. So it's very easy to maintain it this way at the folder level. What I am going to do is just to say File, New, and create a new project. Inheritance. Inheritance, and this is week 13 officially, so that's the name. So this is the idea of inheritance. To specify the right file type. Okay, something like that. How about this? Class rectangle. Which has an integer width, an integer height, constructor. Start with width, I guess. For now, I'll just write it in line using constructor initializer syntax. So using width, initialize with width, and then height right here, initialize with height. This constructor will initialize width and height. Okay. I will also add something called void draw. This is a mockup, obviously. There is no draw, there's just print. Rectangle. Right, height and width. Okay, so all of this is my class named rectangle. There is also a class named circle. I need a semicolon to finish this. Class circle. It has integer radius, and it has public constructor that takes radius and doesn't do anything but populates just like that. And it also has something named draw. And clearly it does something very similar, but prints another message. At this point, for debugging purposes, this is a circle, and it's just going to print its radius. Okay. Okay, how about this? Now this is what I can do. Circle, we'll say radius is 5, okay? 5 units. And then rectangle, rect, I don't know, 10 and 20. Okay, so we can effectively create objects. But how could I do this? Right? Something like this, you know, I don't know what to put here. Perhaps something named, I don't know, some sort of a shape. Vect shapes. And how do I then say vector? Push back circle. And at the same time push back a rectangle. And then maybe create a a loop, some sort of a for loop. I'm far from there just yet, but so that I can basically do something like this, like some index have some index, right? And in this loop, actually I could probably write it something like index is less than vector size plus index, use this index access to my vector, and basically say shapes draw. For each one of them, call draw. Doesn't it make sense to populate a dynamic container with some objects and then uniformly say draw? And once populated inside the vector, once created and populated inside the vector, forget about what type of it is. If it has this uniform interface, draw, why not just call it and make sure that this code works? How can we get to this level?